Yes, we can see it.
Okay, thank you. So yeah, I'm Mike Dillinger, and I'm at LinkedIn. And let me just tell you a little bit about my experience. Just in case you haven't seen this definition before, experience is a polite term for all the mistakes that you've made at work. So here's an example. I have a lot of experience building knowledge graphs, and the translation means is I can't tell you how many times I've screwed up. My experience has a lot to do with taxonomies and ontologies at LinkedIn. So I've been designing and implementing taxonomies for a range of entities at LinkedIn. And that includes products, as we've been talking about already, and taxonomy of companies into industry groups. We've worked on job titles, professional skills. It's really very varied. Before that, I worked on machine translation for quite a while. I led the deployment of the first machine translation system at eBay, which is why I recognize some of the problems that Joe was talking about. And I did some academic research before in knowledge representation and human language understanding. Okay, so my lesson number one is a lot of the time we're kind of shooting ourselves in the foot. Knowledge graphs is a very new area. There aren't a lot of people who have the experience that Joe was talking about, or that this group has actually. So I keep just don't know how to do yet. So that's my first lesson. The second one, and this is really surprising for a lot of my engineering friends, is my lesson is don't clean up your data. Oh, by the way, if you want to unmute and ask questions or tell me I'm wrong in the middle, that's absolutely fine. I actually prefer it that way. And I'm saying this because I built a taxonomy team at LinkedIn of almost 40 people. And this is a request that we got very frequently. Oh, go and clean up the data for us. And then my question now is, well, if we fix or delete the bad data, then how can we make the models more robust? So that is kind of counterproductive. And then how can we define bad data? So in the context of someplace like eBay or LinkedIn, where there's lots of user-generated data, this gets very, very, very complicated. And another point with this is, well, who's going to want to be treated like a cleanup team? So this is a problem that I see all the time, where there's a significant mismatch between the way the engineers and the non-engineers are treated and interact with each other. And that leads to a lot of problems. So for all these reasons, I say just don't clean up your data. It doesn't make any sense to clean it up. Sure, you can partition your data into different kinds. I call it enriching the data. So if you have something that's misspelled or just incorrect, you can put right next to it the correct so-called version. The key thing here is, in terms of lessons learned, is we need a diverse team of partners. Okay, and they have to be partners, not service providers. So what I like to do is promote joint OKRs instead of having OKRs for the engineering side and then just ship out some of the work to other teams, like a taxonomy or a linguist team. Okay, here's one. I don't want to insult anyone, but this is a lesson learned, and I'll tell you why in a second. Okay, so this is, I think, putting an engineer in charge of doing knowledge graphs and taxonomy and ontology work is like asking a translator to build an MT system. So they have some of the knowledge that's necessary, but there's a big chunk of knowledge that's very important that engineering training doesn't provide. Okay, so I would say knowledge graphs are not an engineering problem or a taxonomy problem or a product management problem. they're a problem for everyone. So we have to have very, very close collaboration between people with all three kinds of talent. Okay? So, and that's because most of the time in my experience, engineers don't have the training in semantics and in the specific domains to be comfortable making decisions about what goes in the graph and what stays out of the graph and what data quality means and what evaluation means even. Okay? And then one of the problems I have seen engineering managers talk about is they know how to manage engineers, but now what happens when there are other kinds of functions on the same team? So we have linguists and taxonomists reporting to engineering managers, and the engineering managers kind of say, how do I evaluate them? How do they help them grow their careers? What are they actually doing? And questions like that. So there's, from a management perspective, there are a lot of complexities in doing this. So the point I want to make here is great engineers are just not enough to build good knowledge graphs. Partnerships with non-engineers are absolutely essential. And I keep saying joint OKRs are one of the ways to go so that everybody shares ownership. This is one I have fun with the taxonomists, because I tell them that trees are basically a waste of time, taxonomy trees. So can we really get by with single parents? I mean, this is what Sung was talking about a little while ago, being forced into migrate away from single parent taxonomy trees. And then we often get these questions about how many levels will we need in the tree, and we just don't know. Then my experience has shown that as soon as you build a tree, some other team needs a different tree. We don't like it organized this way. We need it organized in this other tree. And rebuilding the tree manually for each use case is just prohibitively time consuming and simply crazy. So trees have this significant weakness. And theme and variations on that question is, well, what if we need to aggregate or visualize the same data in different ways? And this is often the case. So marketing wants to aggregate things different from the ads people want to aggregate things differently from the insights or analytics people. I see this happening all the time. So some of this comes from the fact that we're often using for taxonomy work the single parent taxonomies that were initially developed in ancient Greece, and there are other better options that we can talk about. Okay, so broader than, this is how we build trees. We say this category is broader than that category. And I'm seeing more and more frequently that thinking this way is basically a recipe for disaster, because parent and superset don't necessarily mean the same thing. And this is, we've run into lots of problems with this, is because we don't define the parent-child relationship clearly enough, and then we get inconsistent categorizations, which means that we can't support inference appropriately. Okay, and it also means that we can't verify whether a parent-child relation is correct or not. So that impacts data quality. And in turn, that means we can't automate it for this verification to validate our parent-child relationships at scale. All of this is because of this the broadly defined or ill-defined relationship between parent and child. So a question I keep hearing is, do we really have to spend the time to define each relation between entities? And my experience, lessons learned, is that, yeah, this is really important if we want to have enough consistency in the data and ensure data quality, and then eventually enable multi-hop inference. So one example is a parent company is not the same as a parent snack, okay, or a parent skill. Definitions make explicit our criteria for evaluation and validation, and they're surprisingly hard to develop. Good definitions that will be helpful in when we have as many use cases as we find at Pinterest, at eBay, at LinkedIn, with any kind of user-generated content. Another thing along the same lines, since I work very much with taxonomies and sometimes work with taxonomists, is that truth is, in my experience, my lessons learned, your biggest enemy, because we assume that assertions or triples or relations can be either true or false. But what if we just don't know, or we aren't sure, or if it's an ill-formed assertion, or if multiple values are possible? So that creates lots of problems. I mean, my question here is, can we get by with true, false, right, wrong, single parents? All of these are implemented when we do clustering, for example, as the assumption that we have disjoint categories. And more I find that this doesn't work for the human work, for classification work, or for evaluation work, the right or wrong. And it's a significant weakness of the algorithms I see, for example, clustering algorithms, that they assume disjoint categories and are hard to apply to situations where there are multiple parents.
3 minutes.
Thank you. So part of this is asking a similar kind of thing. Can we get by with Booleans and enums, which are forms of this true-false distinction? Or do we have to use more richer data? Okay, so now we use continuous valued weights as confidence scores inside models. I suspect we could use them for evaluation as well, and data. Okay, so present company accepted. Basically, no one else knows how to build knowledge graphs. Okay, and there are no college programs, no best practices. There are very few relevant tools. We have very few colleagues outside of this small group here to ask questions of. And this means that product people don't know what knowledge graphs are for. Management doesn't know how to evaluate progress. So we work in an environment of very much uncertainty. Most of my engineering colleagues don't know how to even think about accuracy or data quality. And the linguists and taxonomists I work with don't have any idea about how to scale up their processes. So we have patience and shared understanding, and everybody educating everyone else are really, really essential in our use case. So here's a funny one. Life is rough. So why is this KG team lead smiling? Well, his team accepts that they don't know what they're doing. So he's enriched the team with new kinds of talent, not just engineers. They help each other more than ever before because they're forced into it. And they have to invent new things together every day. And that makes knowledge graph work that much more interesting than many other areas of application. Okay, that's my... Thanks for your attention. I appreciate it.
Yeah, this is a very interesting presentation. Thanks, Mike.
Okay, thank you.
It's not a traditional way of presentation.
No.
Yeah.
Try. Yes.
Right. Questions?
Please go, Song.
Yeah, Mike. Yeah, actually, I just I think this is a very fantastic presentation. I learned a lot. So one question on the parent-child relationship.
Yeah.
So actually, I think in Pinterest, yeah, we have the similar feeling that at the moment, right, we only use one type of edge, which is parent-child, to describe so many different relationships in the taxonomy nodes, right? But however, on the other hand, if you really, I mean, try to categorize each edge type differently, then my question is that, I mean, where is the trade-off? I mean, how we can reach this trade-off? Because what I imagine is that if you really, I mean, try to distinguish so many edge types, then I think that might be complications in constructions and also as well as the downstream signal upgrades.
Yep. You're absolutely right. So we have to balance here the trade-off between data quality and practicality, right? So the key thing here is that, so I'm trying to find here an example that you cited that, where did it go? Oh, I think it was travel. So you have a category called travel
Mhm.
and subcategories with things like restaurants and hotels, right? So the standard, the standard assumption in taxonomy building is that the entities in one taxonomy are all of the same type. Okay, so hotels and restaurants and travel are not of the same type. So that means it's going to be difficult for you to be able to define the relationship between them, because essentially what you're putting into the tree is, a broader definition that's something like related to. Okay, now how are you going to explain to people how to annotate that? And how are you going to judge whether it's correct or not? Right? Because it's so vague and open that doing it that way creates more problems for you with respect to consistency of the data, of the knowledge base. You see what I'm saying? So it may be that for some of the high level categories, it's more important than lower level categories. I'm not sure. But this is a big lesson learned for me, is that whenever we skip the step of defining things carefully, we get into very deep trouble, right? Because then the data doesn't work right and the evaluation doesn't work right, and we get lots of negative feedback from the users.
I see. Got it.
Hi, Karthik.
Hey, I had a question. So I mean, amazing insights. Actually, I totally loved it. I had one question regarding the measurement aspect. Right? I often get asked this question. Do you think the how complete is this taxonomy?
Horrible. Yep. We have no idea. So completeness of the taxonomy, you can measure in a couple of ways. So what we usually use to measure it is the terms that you want to cover. Okay, so that's what I call string completeness. Okay, can you take, of all the strings that you have, for example, if you're doing a taxonomy of the values in the job title field, okay, how many strings do you have? And how many of those can you cover correctly? Right?
Okay.
And how many of those are just not, there's no room, no place to classify them. In our case, for job titles, we have more than 165 million strings. So coverage is a bit difficult. So that's one kind of coverage. Another kind of coverage is what I call concept coverage. And that's things like, well, what kinds of concepts do you want to be categories in your tree? Okay, for example, in our products and services tree, do we want a node for fintech or martech or edtech? Do we cover all of those concepts? That's harder to do because we don't have a good list of the target concepts anywhere. But it's another way that people try to assess coverage.
Okay.
That's what I have.
Okay. Because
Yeah.
it's a really hard one, actually. Yeah.
Yep.
And people find out gaps in your taxonomy only when they see that they come across a certain entity and they realize that they're not able to classify it to a node in the taxonomy. That's when they find out. So you always, get an impression from people that it's incomplete.
Sorry to interrupt. Yeah, I think I remember that Professor Ren Xiang, I think you have some papers on how to construct the taxonomy regarding this complete problem, right? Did I remember wrongly, or?
Yeah, we have work on that. I think with kind of collaboration with also Jiawei Han's team. But I mean, I don't think we have any result that it's really in the production quality. I mean, like expanding the taxonomy by, let's say, twice of the size of the concepts or more. It's with certain precisions, it's something durable. But I don't think the precisions we are producing there can be like, let's say, high 90s, which can really be confident to put into the products, right? Yeah.
Right.
The type of trade-off here is like probably running algorithms would just be creating some candidates, and then still need to do a bunch of very expensive verifications or filtering afterward.
Exactly. And this is a question we get very, very frequently is, oh, how accurate is it? The product people always want to know that. How accurate are your classifications? That's like,
right.
How can you say if there are 15 different ways of classifying things, how can we say how accurate ours is?
Yeah, but more often of the time, probably we can discuss more in the kind of the just roundtable phase with is like no one seems to be always agree on the schema of the taxonomy. Like when you move from one set of user to the other set, they are not happy with it. So, and even there's this specific jobs called ontologist. I don't know what exactly they are trying to do, but I guess they're trying to have a human in the loop procedures to try to reach to a consensus on how to define this type of taxonomy.
That's right.
But still, I don't think that only works for a small group of people, right? Let's say your team change, your product change, some management levels kind of insights come in, everything gonna change again. Yeah.
Yes. So that was my point with taxonomies, is we put a lot of effort into building one tree, but having one tree, as you just said, often doesn't work because the users don't understand it, or marketing doesn't understand it, or.
Exactly. That's what I feel like. I'm not, in terms of doing research, I'm a little bit hesitating on this because the problem itself, it's not super well defined as an engineer can be very happy to work with, because engineers always want to work on some very clean and well-defined problems so they can focus on coming up solutions. But then you have these requirements changing every day, then they might lose some confidence.
Or lose their marbles.
Yeah.
It drives everyone crazy when the requirements change this much.
So Mike, really, really interesting presentation. I'm wondering, are you saying we need to maintain a sort of, flexible knowledge base, knowledge graph, and for different tasks, right? We may expose a subgraph, right? It could be a hierarchy, right? Because for certain tasks, people do need a clean structure, right? But for certain other tasks, right, they may not care. Right?
That's right.
Okay.
That's right. Yeah. So my intuition is that we need to store a feature matrix and generate the taxonomies or the categories on demand. Right? We've seen, even this small group here, we've seen already use cases where we need different ways of aggregating. Okay, for one of the taxonomies that I just built, I had to have 2 different structures of the same categories for different use cases. I think this is a general problem. So that thinking in terms of trees is actually shooting ourselves in the foot. That's the point that I'm trying to make.
Totally agree. That's why I'm moving to the graph next year. All right.
Yes, you can think of a tree as a projection of a graph or a multi-dimensional data structure, and you can project it onto a tree for one. And there are different things as well. If you're using trees, I've seen cases where people want the levels in different orders. Okay, and we can't generate that automatically at this point. We have to redo it manually.
That has to, we can only tackle that with building 2 trees, right?
Yes, at the moment.
Yeah, we really don't want to go there.
Storing data as a tree is not the most efficient way of doing things.
Okay. Very good. Okay. All right. So we can discuss more on during our roundtable session.
Okay, thank you.
Thanks, Mike. All right. So our next speaker will be Professor Xiang Ren from